So in this video, I'm going to talk over all the functionality of the Project Optimize tool. We can always access the documentation up here in the top right, and then we have two different types of searches we can do. We can search the entire project, which is obviously going to take longer, or alternatively, we can use the search specific folder. To add a folder to search in, so you can click down here in the content browser, select a folder, and then add folder location. But in my case, I'm going to use the entire project. Next up, we're going to go through all the optimization options and I'll explain them very briefly. So first up, we have static meshes that have no LODs. So basically static meshes that don't have any LODs at all. And you can see 59, so there are quite a lot in this project that you could get some easy wins with. Next up, we have static meshes that have a certain amount of materials. The more materials you have on a static mesh, the more expensive it is. So if we run that, you can see we've got two. You can also move this slider around. For example, we could look for one, so there'll be lots and lots here. Next up, we can look for how many UV channels static meshes have. So if we look for this, you can see the standard skybox that comes with a reel has 5 UV channels. So if you think about reducing the amount of UV channels to optimize it, I would just double check to see what those are actually doing, as I would imagine if they have 5, it's probably very purposeful here. Next up, we have static meshes that have over a certain amount of verts. So the more verts, the more expensive. Ideally here, you'd be looking for smaller assets that have high vert counts, because in theory, smaller assets shouldn't need to be so dense. So finally, for static meshes, we can see whether they have Nanite enabled or disabled. So if I look for Nanite enabled, you can see we have 3 static meshes in the project with it enabled. And then if I switch it to disabled, there are a lot more, 56 in the project with it disabled. Next up, skeletal meshes. These are very similar to the static meshes, so I won't go into too much detail. Skeletal meshes with no LODs. Skeletal meshes with a certain amount of materials. Again, less materials is more cost effective. And then we could also do skeletal meshes with a large number of verts. So characters generally have a lot of verts, so you probably need to put a higher number in for this one. Next up, we have materials, and we can look for materials using translucency. In this case, I would say look through and try and find if there's a material that doesn't need to be see-through effectively. So you could set it to opaque or masked. Then we have materials that are using two-sided. Two-sided obviously more expensive, but things like foliage here need it on. So both of these I think are fine, so I wouldn't change that. Then we have list all master materials. So this is an interesting one. Basically, you can see we've got 73 materials. I think probably quite a few of these are doing similar things. Like these materials internally probably are very similar. So if this shows you have a lot of materials that are very similar, consider making a master material and then changing some of them into material instances of that master material, which will be more optimized. Next up, we've got textures. So look for a non-power of 2 texture. Non-power of 2 textures won't compress as well. You can see here, so the Y is not a power of 2. So next we can look at specific texture sizes. So you can use the slider to change the number we're looking for. But ideally I made this to look for large texture sizes that you can consider optimizing and reducing. For example, there are 110 2048 textures in the third person template project, which is a large amount of large textures that probably don't need to be that big. So next up we have sounds that have no concurrency. Now this will search for sound cues as well as meta sound sources. If you don't know what concurrency assets is, it's basically a good way to control your audio memory. So you can limit how many times a sound will play at the same time, either globally or locally per owner, per asset owner. Next up, under miscellaneous options, we can look for unused project assets. Now this is going to kick up a warning because it does take quite a long time to go through. The reason being, it needs to load every single asset in your project and then check the references on that. So it has to fully load each asset. So you can cancel that if you don't want to do that. But I would say if you are going to do it, make sure you save before you run it. And you can run it using this button here. If you find that your project is just too big and it's taking a very long time or it's even crashing, consider using search specific folder and then running this, because then you can break it into smaller, more manageable chunks for the tool. So with the power of editing, you can see it's kicked out the results. However, it did take about 30 to 40 seconds, and this is just a third-person template project. Important to note that just because these say 0 references doesn't actually mean they're not being used or not going to be used. For example, this jog forward animation isn't hooked up to anything, but it may be waiting to be hooked up by somebody else, so keep that in mind. So then we have optimizing foliage, so we can look for casting shadows on foliage actors. As you can see here, I broke it down into 3 different types of shadow casting that are in these foliage actors: dynamic, static, and contact. And then finally for optimizations, we have blueprints. So we can search for replicating blueprints. As you can see, I've got 2. Then after that, we've got greater than or equal to net update frequency. So as you can read in this little bit here, net update frequency is how often per second an actor is going to be considered for replication. So a high number is bad, as in heavy for the network. A low number is less heavy on the network, but your actor will be replicated less often. Here you can see the number, and then underneath I just put if the actor is replicated or not. And then the final blueprint one is network cull distance. So this is the max distance the blueprint's going to be relevant. So this is the distance that something will be replicated at. So you can add zeros and remove zeros here. The network cull distance is normally quite a large number. So in terms of functionality for bugs, we can look at the static meshes, and we can look for static meshes with no collision. So you can see these have no simple collision, but they sometimes can have other stuff in them. So this one's using complex as simple, which makes sense because it's just a cube. So the difference between a simple cube collision and complex as simple doesn't make a difference. We can also look for static meshes that have missing materials. You can see we've got 2 static meshes that are missing materials, and I tell you the material slot that has the problem. Next up, we've got skeletal mesh bugs, and we can look for missing physics asset. Missing physics assets for skeletal meshes can cause problems like visibility issues and other bound related problems. We can also look for skeletal meshes that are missing materials, very much like the static meshes. In terms of material bugs, we can look for missing physics materials. And as you can see, because I'm using the third person template, which doesn't have any physical materials set up, basically every material in this project does not have a physical material applied. Physical materials are great for making per material sounding stuff, so bullet impacts on wood and stone and stuff like that. So next up, we've got texture bugs, and we can look for LOD bias value changes. So if you don't know what LOD bias is, you can see here, this texture was imported at 2048, but because it has a LOD bias of 2, its in-game texture size is going to be 512. So you can use this to reduce the size of textures. I stuck this in the bug section because you may have a texture that seems very low in engine, and it's because somebody has reduced the LOD bias value here. You can also use this kind of as an optimization. So if I put the LOD bias to 0, and we can look, say, at this statue, which is a 2048, and then question whether that texture actually needs to be that big. If you knew your game and you knew that the statue was a small asset, this doesn't need to be 2048, hypothetically. So next up, sound bugs. So we have 2. We have no attenuation settings. This is going to work for sound cues as well as meta sound sources. And this is basically looking for attenuation settings, so the distance that you can hear a sound from. And if you look here, it'll either have no override attenuation or it'll have no asset plugged in. So next up in sound bugs, we have no sound class asset. And that same thing, meta sound source as well as sound cues. And if we double click, we can see here, this is the sound class. Sound class is important if you're allowing a player to change the volume of certain things, so music, UI, effects. If you don't have the correct sound class plugged in, then the sounds won't be affected when they should. After that, we have miscellaneous bugs. So we've got project redirectors. Project redirectors, players won't really experience, but they're not great to have in your project, and they will make your project a lot more solid if you fix them up. Then finally for bugs, we have foliage bugs. And for this, I've only got one. I've got missing mesh. So if we click this, it just means that there isn't a mesh set in the foliage actor. So then finally, we have the name convention section of the tool. And you can see here, there's a list of different naming conventions for different asset types. If I run the animation blueprint, which commonly is ABP underscore as a prefix, and then we can hit this button here to run a search over all the assets in the project. We found an animation blueprint that isn't using the prefix ABP. So I made it so you can easily change these prefixes because I know different people have different preferences. So you find the folder where the tool is, and we go into the elements, and then we're looking for this data table here, DT naming conventions. So when we open this up, prefix to check for, this is what we're looking for. And you can see there's the ABP, so you could change it just here to whatever you wanted. And then when you next run the tool, that change will appear in this list. And there we go. We've sped through all the functionality of the tool. I hope it made sense, and I hope you can weed out problems in your own project using this tool.